Good afternoon, my YouTube viewers. It's Crystal here. I just wanted to make another video for you. In this video that I made, what I wanted to talk about was the Poisson distribution. The Poisson distribution is a discrete distribution, and it's used in statistics. So basically, the first thing that we're going to do is we're going to talk about how to create a Poisson distribution in Python. So you're going to use scipy.stats Poisson function, and you're also going to use matplotlib. So the first thing that we do is we generate the Poisson distribution with a sample size of 10,000. So data equals Poisson.rbs, brackets mu equals 3, size equals 10,000. So RBS means it's a random variable. And then what we're going to do is we're going to use matplotlib to plot it. So we plot this Poisson distribution using matplotlib, and you can see that we have a right skewed Poisson distribution. And so the skewness actually depends upon the lambda. Depending upon the lambda, depends upon how skewed it's going to be. And then so we're going to create another Poisson distribution, and this with a little bit extra code, but we're going to use NumPy as NP to create a NumPy array. And then we're going to use matplotlib.pypy as PLT to visualize it. And then we're going to use scipy.stats as stats to use the SciPy formula. So the first thing we do is we define a range of k values. So k equals np.arange 0, 20. And then we calculate the PMF. That's the, let me see what PMF is. Probability mass function of the distribution. So PMF values equals stats.poisson.pmf k and then lambda rate. And then we're going to plot it using matplotlib. And this plot is a little bit different. So we're going to plot it plt.stem, we're going to use k, PMF values, and then base FMT. And then we're going to X label as number of customer arrivals is k, and then the Y label is probability. The title is Poisson distribution, k equals 5, and then X ticks equals k, Y lim equals 0 to 0.3, and the grid is true, and then we're going to show it. So this is a Poisson distribution with lambda equals 5. So you can see that it's still right skewed, but it's a little bit different from the previous Poisson distribution that we made. So we're going to calculate the Poisson distribution if the probability is equal to some values. So we're going to use scipy.stats and the Poisson function. So probability equals Poisson.pmf, and k equals 5, mu equals 3. So k is your, I think it's your lambda, and your mu is your mean. And then the probability is 0.1, which isn't very good. So we're going to check the probability of k or fewer events occurring. And again, we're still going to use scipy.stats and the Poisson function. So calculate the probability of selling 4 or fewer footballs in a day when the average is 7. So probability equals Poisson.cdf, and CDF is cumulative distribution function, where k is 4 and mu is 7, and so your probability is 0.17. So now we check the probability of more than 4 events occurring. Again, we're going to use scipy.stats, we're going to import Poisson, and then we're going to calculate the probability of selling more than 20 cans of tuna in a day when the average is 15. So probability equals 1 minus Poisson.CDF, and K equals 20, mu equals 15. And then the probability is 0.08. So whenever you are trying to calculate the probability and the value is over a certain amount, you have to do 1 minus the CDF. So now we're going to check the probability mass function. That's your PMF. We're going to import scipy.stats as stats, and the parameters are the lambda rate equals 5. That's your average rate, and K equals 3. That's your number of events. So we're going to calculate the PMF. PMF value equals stats.Poisson PMF. That's your probability mass function. And K is 3 and lambda rate is 5. So I think lambda rate, I don't know why they said lambda rate. I would prefer to say mu, but that's why they said it. And then so we print it, and the probability is 0.14. So that's 14%. So now we're going to check the cumulative distribution function. Again, we're going to do import scipy.stats as stats. And so we're going to check the lambda rate equals 5 and K equals 3. Calculate CDF. CDF equals stats.Poisson CDF. K is 5 and your lambda rate, no, K is 3 and your lambda rate is 5. And then we print the probability, and it's 26%. Now we're going to check the survival rate, and we're going to use the scipy.stats as stats, and lambda rate is 5, that's your average rate, and K equals 3, that's number of events. Calculate the survival function. SF value equals stats.Poisson.SF, and then brackets K and lambda rate, and then we print it off, and your survival function is 73%. Now we're going to calculate the hazard function. So we're going to import NumPy as NP to create your NumPy arrays. We're going to import matplotlib.pyplot as PLT. And then we're going to define the rate parameter lambda for the Poisson process. Lambda rate is 3, and then the range is going to be T equals np.linspace 0,10, 1,000. So that's your range of T values. And then we're going to calculate the hazard function values, and that's your constant hazard rate. Hazard values equals np.full like T, lambda rate, and then we're going to plot it using matplotlib. And then when you plot it using matplotlib, it's going to be, the hazard rate is going to stay continuously at 3. So that's not very good. So I tried to get the hazard rate, but this particular distribution is not really a distribution that's good for the hazard rate, but that was what we got for the hazard rate. So it's going to stay at 3. So now we're going to use the percent point, the function, that's PPF. I said PPT, it should be PPF. And then lambda rate is 5. P, your cumulative probability is 0.4. So now we calculate PPF. PPF value equals stats.Poisson.PPF. P, lambda rate. And then your PPF probability is 4. So now we're going to check RVS. That's a random variable. So So we're going to use scipy.stats as stats. That's the function or the library that we're going to be using. Lambda rate equals 5, size equals 10, and then we're going to generate random variates. So random variates equals stats.poisson.rvs, lambda rate, and then your size. And then so what it does is it just prints out 10 random variables and a Poisson distribution. So now we've got a question that we've got a practice question. It says on average 30.5 customers arrive per hour at the checkout counter during weeknights. What is the probability that 25 customers arrive at this checkout in a given hour during a weeknight? So we're going to import scipy.stats as stats. The parameter is lambda rate is 30.5. That's your average rate or your mean. And K is 25. So that's number of customers. Probability equals stats.poisson.pmf K, lambda rate. And then you print that out. And the probability is 0.469. So that's about 5% probability that 25 people will go to that checkout counter. The next one, what is the probability that fewer than 33 customers arrive at this checkout counter in a given hour during the weeknight? So again, we're going to use scipy.stats as stats as the library. The lambda rate is 30.5, that's your mean. Your K is 32 because we want fewer than 33. So 1 less than 33 is 32. So the cumulative probability equals stats.poisson.cdf. K is lambda rate. And then you print off the probability, and it's a 65% probability that fewer than 32 people will arrive at the checkout counter. And then now we have the last one. What is the probability that the number of customers who arrive at this checkout counter in a given hour on a weeknight will be greater than 35? So we're going to import scipy.stats as stats. That's the library we're using. Lambda rate is 30.5, so that's your average. K is 35, that's your threshold value. So now we're going to calculate the survival function. And so survival probability equals stats.poisson.sf K, lambda rate. We're going to print off the probability, and it's going to be 18% probability that greater than 35 people will arrive. And that's it. That's it for the Poisson distribution that I wanted to go over this Poisson distribution to give you some example questions, some practice questions, so you can know a little bit about the Poisson distribution and how to calculate the probability and give you some insight into that. But I'm sure that it's going to take a lot of practice to become proficient at it. But we'll see. We'll just keep on working and see what happens. So thank you so much for watching my video. If you like my video, please like and subscribe. And I look forward to making another video for you very soon about a technical subject.